Hello guys, let us start the today's CodeChef contest discussion session. Now, how many of you given the contest? Okay, it's fine. Now let us start the discussing the first problem of the today's contest. The first problem is election hope. As you can see, we have to check whether the y is greater than or equal to 2 times of x. If y is greater than 2 times of x or equal to 2 times of x, then that means the chef has dominated the another person, and it is pretty easy. X greater than or equals to 2 into y, print yes or no. Now let us move on to the next question. This is the second question of today's contest, spell spice. In this question, what they are asking is they have given two arrays which they have given two pair of values. It is an array of pair of values where one element represents the volatility and another element represents the strength. As you can see, what we have to find out is to maximize this value. We have to maximize the ai into vj, vi into aj. If you observe the constants clearly, you can do the brute force approach. What is the brute force approach is you can iterate from you can iterate the values of the array and square times such that you can do the trial and error process with each and every value, and you have to choose the maximum value. Here you can see the solution of the spell space problem. Here what we have done is here what we have done is we have taken two vector values and we have taken the values pair of values of the volatility and the strength, and after that what we have done is we have iterated the loop two times from 1 to n minus from 0 to n minus 1, and for each value we have taken the second pointer from I plus 1 to the last element. So what we are doing is we are checking for each value of the v, we are taking the another value in the arrays so that we can perform the trial and error process for the each pair we can form, and checking whether and finding the maximum value of all of them. Like, it's a bit clear right now, it's not something like big logic behind it. What we are doing is simply we are taking all of the possible pair values and we are simply checking getting the maximum value out of them. That's it. I think it's clear right now. Let us move on to the third question. Okay, let us see the third question of the today's contest. The third question is large differences. In this question, they have given an array of length n and a positive integer k, and they have what they have asked us is maximize this sum of adjacent differences value. Where that is, we have to maximize the difference between adjacent elements. To do that, we have given a operation, single operation, that is we have to replace the any value of the array with x, such that x lies in between 1 to k, and it has to increase this summation value. If it doesn't increase the summation value, there is no need to perform the operation, because it has given that the operation is performed at most once, so that you can perform the operation at most once, or is there is a choice that you don't make any operation here. Like if it doesn't increase the summation value from 1 to k, any elements doesn't increase the summation value, then there is no need to do the operation, because it decreases the original sum, so there is no need to do that. So our aim is to improve this summation value. So as the objective is clear right now, we can proceed to the code part. Let me show you the code. Before getting into the code, like, let me explain some logic behind this. Like, here, before doing the problem, okay, if you change the value ai, then what are affected? Ai is affected, and ai, the differences, what we are taking is the value of the differences. So two values are affected by the replacing of the ai. One is difference between minus 1 and ai, and another is ai minus ai plus 1. So you are affecting essentially two values by replacing this value. So while checking also, you have to check whether the sum due to the, if let us suppose this is value x and this is value y, you have to check whether we have maximized the x plus y value, essentially. Like, it doesn't like you are taking consideration considering only this value or considering this difference. You have to consider both of the differences and check if the whether the replacement of ai benefited the both. If you check the single difference, it may leads to like it doesn't increment this value. So what we are essentially to do is we have to check the both x and y values, and after that we have to proceed to check for all of these values. Then how do we check whether, like, there is another optimization lies in this, like how with which value we have to replace the AI? That is the second question. The first question is like what are the differences considered? What are the differences considered? Here the differences are considered between ai minus 1 to ai and the ai minus 1 ai plus 1 to ai. So two differences are considered. That is the first step. And the second step is value, what value to replace the ai, such that it maximizes the difference between these two values. Like, here what we can do is we can check from 1 to k values. We can check from 1 to k values, and for each value we can check the differences and pick the maximum out of 1 to k. And another thing what we can do is we can take the, like, this leads to the time complexity of approach, like k into n. Here it's like tends to 10 to the power of 9 because 10 to the power of 3 into 10 to the power of 6. So like it gives the TLE. If you do this brute force approach by replacing each of the element in the array with from 1 to k values and checking if the sum of the differences is increasing or not, this trial and error approach will give you TLE. So what do we have to do then? Like we have to optimize our selection of the AI value, AI element. To do that, we can use one, like it's maybe similar to one of the topics you have know, like binary search. Like in the binary search, what we have to do, we do that like to maximize the difference. One thing we can do is we can take the median value. Like we can take the median of AI minus one and AI. Because if you take any other value, it simply increases this value and decreases this value so that it would be compensated. Like if you take a number line, if it goes this way and if it goes this way, like there is a restriction here, because like you can't take infinite. You can only take from 1 to k. If you can take the infinite value, you can go up to the infinity. You can go up to the infinity. It doesn't work like that. Here what we can do is we have to take 1 to k. The 1 to k may enclose these two values, or maybe one of. Hello, I think I am audible now. Basically what do we do is we select AI value based on the whether the median values of the AI minus 1, AI plus 1 lies in the 1 to k. Like to maximize the differences between these two values, we have to maximize this difference and we have to maximize this difference also. So we have to maximize the two differences at the same time. To do that, what do we do is we can, like the number range is not infinite here, the number range is finite. So what we have to do is we have to select the values from 1 to k. While choosing from the values from 1 to k, we will select the median value of these two values, and if it lies in between this 1 to k, we directly select the median value. If it doesn't, if it lies outside, then we will check with the whether the original value or k brings the biggest difference or 1. We will compare these three values, 1, k, and the already given value in the array. And while comparing these three, we will choose the optimal one, and after that we will remember this value while remember the value which brings the maximum difference by replacing the a, whether if it's greater than 0 or not. Like if it's maybe greater than or equal to 0, we will check it, and if it's greater than or equal to 0, we will remember it. And while proceeding from 1 to n, we will do this constant operation from 1 to n. We will do this operation. What it is, we will essentially replace the AI value with the median values of the AI minus 1, AI plus 1, and check the sum of the differences is greater than or greater than or equal to 0. If it is greater than 0, then we will remember the value. And for each AI we process, we will remember only the maximum change. That is, we will already pre-compute the summation of all the sum of the differences at each position in another array, differences array. Let us call this as differences array. Like we will store the sum of the differences with each of the a value in this array, so that later it is easy to compare. Like it's reduces the complexity of the code. Let me show you the code. Here this is the code. First we have taken the test cases, and after that we have taken the value of the array elements, and after that what we have done is we have calculated the array of the sum of differences. After that what we have done is we have taken the median value here. We have taken the median value here, and for me, if it lies in the, if the ai minus 1 and ai plus 1 median values lies between the uh, the these thing, uh, these 1 to k, we are checking with the original differences and the new difference, and we are taking the maximum change. Okay, like we have to change a small implementation here, because like for the last element it doesn't have the previous difference, and for the for last for the this goes to the same last element also. For the last element there is no after element to compare with it, so we are considering the sum of the value of the differences for them in a separate way. After this whole thing is done, we are taking, after this whole thing is done and we have get the maximum value using this max function, we are just printing it simply. What here we have done is we have taken a max sum of differences array, and after that we have taken three cases. One is the, for one is for first element, one is for last element, another one is for middle elements. For each middle element we have checked whether, we have checked the median value of the a minus 1 and a plus 1, and whether it lies in the 1 to k range, and after that we are simply calculated the absolute difference by replacing the median value and with the original value, and we have taken the maximum value among them, so that we can get the answer. Let me run the code.